Section 6.1 Part 1, this whole chapter, Chapter 6, is going to be about rational expressions and functions. Today we're going to start off just talking about some things about rational functions. And first off here, we need to remember a couple of things. First thing we want to remember is a fraction cannot have 0 in the denominator because that makes the answer undefined. Or another way we could say it that has to do with the problems we're about to do, we could say the function value does not exist if we're asked to plug something into a function and we end up with a 0 in denominator, we'd say, well, that function value doesn't exist. So what happens is if you have a number on top, but you end up with 0 on bottom, that answer is undefined. But keep in mind, if the 0 is on top with any number besides 0 on bottom, then that equals 0. And if you can't remember that, then your calculator will tell you the difference between those. If you try to put in like 5 divided by 0, it gives you an error because it's undefined. But if you were to put in 0 divided by 5, it would tell you that's 0. So it's pretty helpful like that. To find the domain of a rational function, which we actually have done before, we set the denominator equal to 0 and solve. So these are the two types of problems that we're going to deal with today, or the two things we need to remember for what we're doing on this one. So example 1 says, use the given rational function to find the indicated function values if a function value does not exist, so state. So what we're going to do is there's basically 3 different problems here, like we could call them A, B, and C. That for part A, I want to take this -1 and plug it in everywhere that I have an x in my function. So it'll be f of -1. And when we plug in negative numbers, we need to put them in parentheses, especially if we're going to put it in the calculator. We have to have those parentheses there for the calculator to do it right. So if we are going to simplify this by hand, then on top we've got -1 squared, which is a positive 1. -2 times -1 gives us a positive 2. And then this -3 stays -3. On the bottom, we've got a change situation so that we have 4 plus 1 since there were 2 negatives in a row. So that gives us 5 on bottom. But here on top, 1 plus 2 is 3. 3 minus 3 is 0. So we end up with 0 over 5, which means our answer is 0. So f of -1 is 0. Now let's do B and find f of 4. So we plug in 4, and since it's not a negative number, we don't necessarily have to put it in parentheses. You can if you want to. And on this one, we can save ourselves some time if we look here at the bottom. 4 minus 4 is really easy to do. And if you see that it's 0, it really doesn't matter what's on top. If we have a 0 on the bottom, that makes our answer undefined. Part C, we're going to find f of 6. So we plug in a 6. So on top, 6 squared is 36. 2 times 6 is 12, so that's -12, -3. On the bottom, 4 minus 6 is -2. In some ways, this is unfortunate that on this particular one we didn't end up having a 0, because that kind of made it easier to simplify, but we'll see it through anyway. 36 minus 12 is 24, and 24 minus 3 is 21, over -2, and that's a just fine answer. We don't need to put that in the calculator and get a decimal. If we could reduce, if it had come out to something like, 6 over 4, which you can reduce, then by all means go ahead and do that. But we would rather it be in a fraction than a decimal, please. Example 2. Find the domain of each of these rational functions. So this is where our little tooltip earlier was helpful, because all we care about on these is the bottom of the fraction. We don't care what's on top. It does matter for some things, but not for what we're doing. If we want the domain, we just take whatever is on the bottom and we set it equal to 0, and then we solve. So subtract 3 from both sides and get x equals -3. Now that's not actually our answer. Our answer is that the domain is all real numbers, which you can abbreviate with ARN, except x does not equal -3. Okay, all real numbers except x cannot equal -3, because we're saying you can plug in whatever you want here except for -3 and get an answer, but -3 is what gives us a 0 on the bottom. So that's what causes problems. On B, if we have two things on bottom, we set both of them equal to 0, okay? Because we have x plus 2 and x minus 6 that are being multiplied together. Then the way to solve that, and we've talked about problems where we just had the bottom equal to 0, but that was a while ago. So we'd subtract 2 on the first one, we'd add 6 on the second one, and get x equals -2 and x equals 6. So that our answer is all real numbers, except this time there's two values that don't work. So we say x cannot equal -2, and then put a comma for 6, because it's like we're making a list of things that x can't equal. On this last one, now this one isn't really any trickier. It's just kind of it might throw you off that there's a squared. X minus 4 squared means that we have x minus 4 times x minus 4. Well, if we set each part equal to 0, then we're saying x minus 4 equals 0. And you can do that twice, but no matter how many times you do x minus 4 equals 0, you should get x equals 4 because you add 4 to both sides. So basically you can ignore that squared there for the purposes of domain. And it's just all real numbers except x does not equal 4. And so our last example, example 3, is basically the same as the examples we just did. It's just a touch harder. On your note sheet that you got for class, if you're actually in College Algebra Prep and watching this, it had a minus sign here for 16, but I actually meant for it to be a plus sign, so you can change that, because again, we ignore the top, but if we want to find the domain, we set the bottom equal to 0, and in order for us to solve that, the only thing that we know how to do so far this year is factor. So we want to say what multiplies to get 16 that adds to get -10. So think about it. To get 16, 1 and 16, 2 and 8, 4 and 4. Well, if I add 2 and 8 together, I get 10. To get -10, I do -2, -8. So I set both parts equal to 0, because now this is where we were with our last couple problems. And solve. And our answer, because we're finding domain, is all real numbers except x cannot equal 2 or 8. That's the first part of 6.1.